Day 457 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2106, maximum fruits harvested after at most case steps. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Fruits are available at some positions of an infinite x-axis. You are given a 2D integer array fruits where fruits of I is equal to the position I and amount I depicts the amount I, fruits at the position I. Fruits is already sorted by position I in ascending order, and each position is unique. You are also given an integer start pause and an integer k. Initially, you are at the position start pause. From any position, you can either walk to the left or right. It takes one step to move 1 unit on the x-axis, and you can walk at most k steps in total. For every position you reach, you harvest all of the fruits at the position, and the fruits will disappear from the position. Return the maximum total number of fruits you can harvest. All right, y'all, so that may seem a little bit confusing, so let's go through these examples just to make sure that we understand this question correctly. So in example 1, we have our input fruits equals a 2D array of integers, first array being 2 and 8, second array 6 and 3, and the third array is 8 and 6. Start pause is 5 and k equals 4. Output is 9. So let's see how they got this output from this input, right? So the explanation says the optimal way is to move right to position 6 and harvest 3 fruits, then move right to position 8 and harvest 6 fruits. You move 3 steps and harvested 3 plus 6, which equals 9 fruits in total. So to break this down one step further, if we look at this picture, so this little human right here, that's us. And we want to collect the maximum total number of fruits that we can harvest, right? So in this case, and we're only allowed to move k equals 4, so we're only allowed to move 4 steps. So to do that, we can move right here to 6 and get 3 fruits, and that's only one step, right? Because remember, it says right here, and you can walk at most k steps in total. So we move 1 step and got 3 fruits. Then we move 2 more steps and get 6 more fruits. So in total, we get 3 plus 6 fruits. In total, we get 9 fruits, and we were able to obtain those 9 fruits in less than 4 steps. If we would have went to the left, we could have went to the left and went to the left 1, 2, 3 steps, but we would have only got 8 fruits. When if we do it and by moving to the right, we can get 9 fruits, and we want the maximum total. So that's why we went to the right and got the 9 fruits instead of the 8. So just in case that didn't make any sense or y'all are still confused, let's take a look at example 2. Example 2 is a little bit more tricky because we have to move to the left first and then to the right, but we were still able to gain the maximum amount of fruits or harvest the maximum amount of fruits that we can. So let's go through it. In example 2, our input fruits is a 2D array of integers, first 0 and 9, then 4 and 1, then 5 and 7, then 6 and 2, then 7 and 4, then 10 and 9. Then once again, let's go over what these 2D arrays mean. So this 2D array means at position 0 or at 0, there will be 9 fruits, right? So 0, there's 9 fruits. At position 4, there will be 1 fruit, right? So at 4, there's 1 fruit. At position 5, there will be 7 fruits. At 5, there's 7 fruits, and so on, so on. So that's what this 2D array means, right? Then we have the start pause equals 5 and k equals 4. This time our output is 14. Let's see how they got that 14. So the explanation says you can move at least k equals 4 steps, so you cannot reach position 0 or 10. So they have 9 fruits here, but since we start at position 5 and we're only allowed to move 4 steps, we can't make it to 0 from 5 because we can only move 4 steps. We can only make it to 1. Sorry, y'all. And similarly to position 10, starting from 5, there's 9 fruits at position 10, but we can't make it to 10 because we can only move 4 steps. But what we can do is go to the left and grab this fruit first, and then come back to the right 3 more and grab the rest of the fruits. So let's continue down this explanation to see how they did that. So it says the optimal way is to harvest the 7 fruits at the starting position 5. So we grab these 7 fruits right here. Then we move to the left to position 4 and harvest 1 fruit, right? So boom, we still haven't taken any steps. We get the automatic 7 because 7 is at 5 has 7 fruits. So we go to the left 1 step, right? That's 1 step down, and we collect an extra fruit. Now we have 8 fruits. Boom. Then we move to the right to position 6 and harvest 2 fruits. So from this 4, we already collected the fruits at 5. We already collected the fruits at 4. So now we go 2 steps to the right, 1, 2 to position 6. And now we get 2 more fruits. And now we have 10 fruits in total. Then we move to the right to position 7 and harvest 4 more fruits. And in total, we moved 1 plus 3, which equals 4 steps, and harvested 7 plus 1 plus 2 plus 4, which equals 14 fruits. So once we go to the right 1 more step, we can collect an additional 4 fruits, and in total we get 14 fruits by going to the left 1 and then to the right 3, and we obtain the 7 at our starting position. So just in case people still need a little bit extra explanation, let's take a look at example 3. So in example 3, our input fruits is a 2D array of integers 0 and 3, 6 and 4, 8 and 5. Our starting position is 3 and k equals 2. So this time our output is 0. Explanation says you can move at most k2 steps and cannot reach any position with fruits. So we're only allowed to move 2 steps, and we're starting at position 3. If we move 2 steps to the left, we go to position 1. There's no fruits at position 2 or 1, so we can't get any fruits by going to the left. Similarly, if we go to the right 2 steps, we can only go 2 steps. We can go to 4, there's no fruits at 4, and then we could go to 5, there's no fruits at 5. So from with this problem, or with this example, it's impossible for us to obtain any fruits because we would have to at least make it to position 0 or position 6 to gain any fruits, but we're only allowed to move 2 steps, so we can't make it to those positions. Thus, our output is 0. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get started. Now, the first thing we are going to do is, so we're going to be using a sliding window to solve this problem. So the first thing we need to do is create our left boundary index of the current window. So to do that, we could just declare a variable called left, and we could set that equal to 0. Then we need a variable to keep the total fruits collected in the current window. So we could declare a variable called sum and set that equal to 0 as well. That's going to keep the total fruits in our window. Then we need a variable to keep track of the maximum fruits collected so far. So for that, we can declare a variable, we can call it ands, and we can set that equal to 0 to start as well. Now, we need to expand the right boundary of the sliding window. So we're going to say for right in 0 dot dot up to or less than fruits dot count. We're going to open up the brackets. Now we're going to add fruits at the right position to the running total. So we're going to say sum plus, sorry y'all, it should be plus equals fruits square bracket right, come outside that square bracket, and square bracket 1 again. Now we're going to shrink the left boundary until the walking distance is less than or equal to k, because remember, we can only move k steps. So we're going to say while left is less than or equal to right, we're going to open up the brackets. And we need to keep track of the distance from the starting position to the farthest left fruit in the window. So we could say let L equal max, open up the parentheses, 0, comma, start, pause, comma, or it's not comma, start pause minus fruits, square bracket, left, come outside of that, square bracket 0. Boom. Now we need the distance from the starting position to the farthest right fruit in the window. So this time we're going to come right underneath that. We're going to say let R equal max, open up the parentheses 0, comma, fruits, square bracket right, come outside of that, square bracket 0, come outside of that, and then we're going to say minus start pause. Boom. Now we're going to use a formula which is going to get us the shortest walking distance to collect all fruits. We're going to, for the first case we're going to go left first and double back to right, or we're going to go right first and double back to left. If either path is within k steps, then we can keep the window. So for that, we're going to say, our formula is going to be, we're going to say if min, open up the parentheses, L times 2 plus R, comma, L plus R times 2 is less, come outside the parentheses, is less than or equal to K, then we can open up the brackets and we're just going to break. Boom. Otherwise, we're going to remove fruits from the left side and move the left pointer forward. So we could come underneath this and we're going to say sum minus equals fruits, square bracket left, come outside of that, square bracket 1. Then we're going to increment left by coming underneath that and saying left plus equals 1. Boom. Now we need to update the maximum fruits collected by coming outside of this while loop right here and saying ands equals max, open up the parentheses, ands, comma, sum. So that's going to return whichever one is larger, ands or sum. Boom. Now we just need to return the best, and it's going to store it in ands. And now we just need to return the best result found by returning ands. So we're going to come right here and say return ands. Now that should be all she wrote, y'all. Let's give it a run before we submit it. Let's see, it's accepted first try. That's what I'm talking about. So let's go ahead and submit it. Let's see. Oh, look at that, y'all. 4 milliseconds beats 100% of users. That's what I'm talking about, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.